together. Okay, actually there are 7 parts in this chapter. Let's go over them one by one. First part is some common properties of simple inequalities. Okay, for each of the property, first I'll list the property itself, followed by some explanation or a proof. And then I'll give you some examples to help you understand, okay? These are the fundamental knowledge we need to solve simple inequalities. Okay, first property is add a real number to both sides of an inequality. The inequality symbol remains in the same direction. In other words, if we have A is smaller than B and C is a real number, then A plus C is smaller than B plus C. Right? This is not very difficult to understand. Suppose we have a number axis, and if A is smaller than B, we have A here, right? And because B is larger than A, so B is somewhere at the right-hand side of A, right? And after we add a number C to both A and B, that means we have translated A and B to the right C unit at the same time to a new position, A plus C and B plus C. Because A is smaller than B, that means A plus C must be smaller than B plus C, right? Okay, note that if we change the strictly smaller than symbol to smaller than or equal to symbol, or change the strictly greater than to greater than or equal, the property still holds true hereafter, okay? So that means if I add an equality sign here and here, this property still holds true, okay? Okay, and then let's see some examples. For example, 1 is smaller than 2, right? If 1 is smaller than 2, we know that when 1 plus 3, the new number is smaller than 2 plus 3, right? Also, or if we have x is smaller than y, then we know that x plus 1 is smaller than y plus 1. Or if we have x is smaller than minus y, then x plus y is smaller than 0. This means we add a y to both sides of this inequality, right? And if we have minus x is greater than or equal to y, we can have x plus y is smaller than or equal to 0, right? Okay, and this also means if we move a term to the other side of the inequality, the plus sign or minus sign in front of the term changes to the opposite, right? For example, if we have x plus 2 is greater than minus y, then if you change minus y to the left-hand side of the inequality, then we will have x plus 2 plus y is greater than 0, right? If you move any term to the other side of the inequality, the sign in front of it changes to the opposite. Okay? Any questions regarding the first property? No? Okay, if you have any questions, just let me know, okay? Okay, let's see the second one. Subtract a real number to both sides of an inequality. The inequality symbol remains in the same direction. Okay, if we have proved the first property, the second one is not very difficult to understand, right? You can treat that minus c is a real number, right? So if you add a c to both sides of the inequality symbol remains in the same direction. Of course, that means you add a minus c to both sides of the inequalities. Inequality also remains in the same direction, right? Okay, so for example, 1 is smaller than 2. That means if you subtract 3 to both sides of the inequality, 1 minus 3 is smaller than 2 minus 3, right? Or if x is smaller than y, we know that x minus 1 is smaller than y minus 1. Or if x is smaller than y, we know that x minus y is smaller than 0. Or if x is greater than or equal to y, we know that x minus y is greater than or equal to 0. Okay? Any questions regarding the second property? No? Okay. So next one. Multiply a positive number to both sides of an inequality. The inequality symbol remains in the same direction. In other words, if A is smaller than B and C is a positive number, then we will have the product of A with C is smaller than B with C, B times C. Okay, how do we prove this? We can start from AC subtracted by BC, right? We can start from here. First of all, AC minus BC is actually C times A minus B, right? C times the difference between A and B because C is a common factor, right? Okay, so we know that A is smaller than B. That means if we move B to the left-hand side of the inequality, it becomes minus B, right? So A is smaller than B means A minus B is a number that is smaller than 0. In other words, this is a negative number, right? Also, we know that C is a positive number. So that means a negative number times or multiplied with a positive number. This must be a negative number, right? So C times A minus B should be a negative number, which is smaller than 0, right? So this means we have, if we expand this left-hand side, we will get AC minus BC, right? AC minus BC is smaller than 0. And if we put this term to the right-hand side of the inequality, we get AC is smaller than BC, right? Okay, so I must say that all the proofs and explanations is to help you understand this property. The key is you need to remember these property here in your brain, okay? So these are the most important points. Okay, for example, 2 is smaller than 3. And then we know that if we time 4 to both sides of the inequality, the inequality symbol remains in the same direction. That means 2 by 4 is smaller than 3 by 4, okay? And if we know that x is smaller than y, and if we time a 2, 2 is positive number, right? If we time a 2 to both sides of the inequality, we get 2x is smaller than 2y. And similarly, if we know that m is greater than or equal to n, and 1/2 is a positive number, right? We time 1/2 to both sides of the inequality, we get 1/2 of m is greater than or equal to 1/2 of n, right? Okay, any questions? No? Okay, the next, the fourth property. Similar to the property 3, in the fourth property, we get multiply a negative number to both sides of an inequality. So inequality symbol changes direction. So that means if we have A is smaller than B and C is a negative number, then if you time a C, both sides of the inequality symbol changes direction. That means AC is greater than BC. Okay, how do we prove this? The method is the same with the previous one. We start from AC minus BC. AC minus BC is actually C times the difference between A and B, right? We can put C in front because C is a common factor. And then we know that A minus B is a negative number, right? And here, this time C is also a negative number. So we have a negative number times a negative number. Then we will get a positive number, right? So the product between C and the difference of A and B is greater than 0, right? And if we extend the left-hand side, we will get AC minus BC is greater than 0. And if we put minus BC to the right-hand side, it becomes BC. So that means AC is greater than BC, right? This is how we prove this property. For example, 2 is smaller than 3, right? But if we times -1 to both sides of the original inequality, for example, 2 times -1 and 3 times -1. So inequality sign here changes direction, right? And you can also verify this. 2 times -1 is -2. 3 times -1 is -3, right? -2 is, of course, greater than -3. Okay, next, if we have x smaller than y, if we time a -2 to both sides of the inequality, the inequality symbol changes direction. So that means -2x is greater than -2y. And for another example, if we have m is greater than or equal to n, that means when we time a -0.5 to both sides of the equation, the inequality symbol changes direction. Therefore, we get -0.5 m is smaller than or equal to -0.5 n. Okay, any questions? No? All right, let's see the fifth property. Okay, this time is the division rule. Divide both sides of an inequality with a positive number, the inequality symbol remains in the same direction. Okay, in other words, if we know that A is smaller than B and C is a positive number, then A divided by C is also smaller than B divided by C. Okay, how do we prove this? The method is the same as we used in property 3. Okay, if we know that C is a positive number, then the reciprocal of C, which is 1 over C, is also a positive number, right? And from property 3, which has already been proved, we know that if A is smaller than B, we can time a positive number to both sides of the inequality, right? So A times 1 over C is also smaller than B times 1 over C. The inequality sign here does not change direction. So that means A over C is smaller than B over C. Right? Okay, for example, if 2 is smaller than 3, we divide both sides of the inequality with a 4, we can get 2 over 4 is smaller than 3 over 4, right? For another example, if x is smaller than or equal to y, we divide both sides of the inequality using 2, then we will get x over 2 is smaller than or equal to y over 2. Okay. Or if we have m is greater than or equal to n, we know that m over 10 is greater than or equal to n over 10. Okay, any questions? No? Okay, let's see the next. Number 6. Divide both sides of an inequality with a negative number. The inequality symbol changes direction. In other words, if a is smaller than b, c is a negative number, then we will have a over c is greater than b over c. Okay, and the method to prove this is the same to the one we used in property 4. Okay, if c is smaller than 0, then 1 over c must also be a negative number, right? From property 4, which has been proved, we have a times 1 over c is greater than b times 1 over c, right? Because property 4 tells us that if we time a negative number to both sides of the original inequality, the inequality symbol changes direction, right? So originally we have a smaller than b. Changes after the direction change, we will get greater than a times 1 over c greater than b times 1 over c. That is, a over c is greater than b over c, right? For example, we know that 2 is smaller than 3, and if we divide both sides using a -4, then we will get 2 over -4 is greater than 3 over -4, right? If you verify this, left-hand side is actually -0.5. Right-hand side is -0.75. Of course, left-hand side is greater than the right-hand side, right? Next, if we know that x is smaller than or equal to y, if we divide both sides using a -1, we will get x over -1 is greater than or equal to y over -1, which is minus x is greater than or equal to -y, right? Next, if we know that m is equal to or greater than n, we know that m over -10 is smaller than or equal to n over -10, right? Any questions? No? Okay, let's see the next one. Property 7. If both sides of the inequality are positive and the exponent n is positive, raise both sides of the inequality to the nth power. The inequality symbol remains in the same direction. Okay. In other words, if we know that a is smaller than b and both a and b is above 0, and also we know that n is a positive number, then we have n to the a to the nth is smaller than b to the nth. Okay, so how do we prove this? We start from the given information, which is a is smaller than b and both a and b is above 0. From this inequality, we can divide both sides of the inequality using a b, right? So 0, a, b. We divide both sides using a b. That means we get 0, a over b, 1, right? This is according to property 5. If we divide both sides of the inequality, the inequality symbol does not change direction. And then we know that a over b is a number that is greater than 0 and smaller than 1. So we can raise it to the nth power, right? Remember that n is a positive number. So this number should be also within 0 and 1, right? And remember that we can detach the number in the middle to a to the nth over b to the nth, right? That means a to the nth over b to the nth is greater than 0 and less than 1, right? Note that b to the nth is also a positive number. And according to the rule 3, I guess. Okay, according to the rule 3, we can time a bn to both sides of the inequality. This will give us, sorry, this is 0. This will give us a to the nth is smaller than b to the nth, right? And so we have proved this property. For example, we know that 3 is smaller than 4, right? And both 3 and 4 is above 0. And if we raise both numbers to the second power, we get 3 to the twice is smaller than 4 to the twice, right? The inequality symbol here does not change direction. Or for another example, if we know that x is smaller than y, and both x and y are positive number, and then we know that if we raise both sides of the inequality to the third power, the inequality symbol here does not change direction. So x cubed is smaller than y cubed. Okay, and for another example, if we know that m is greater than or equal to n, which is greater than or equal to 0, that means both m and n are non-negative, right? And we raise them to the 1/2 power. Then we know that m to the 1/2 is greater than or equal to n to the 1/2, right? Okay, any questions? No? All right, let's see the next property. Property 8. If both sides of the inequality are positive and the exponent n is negative, okay? So this time the exponent is a negative number. Raise both sides of the inequality to the nth power. The inequality symbol changes direction. Okay. How do we prove this property? Also, we can start from n is a negative number, right? If n is a negative number, then we time both sides using -1, and then we can get minus n is actually a positive number, right? And then according to property 7, because a is smaller than b, and minus n is a positive number, we can raise both sides to minus n's power, right? And inequality sign does not change direction. So that means a to the minus n is smaller than b to the minus n, right? And note that we can divide both sides of the inequality using a b minus n to get the inequality here, right? And the number in the middle can be combined to a over b to the minus nth power, which is a to the b's, a over b to the minus 1's power, and then to the nth power, right? Which is b over a to the nth power, right? And then we time both sides of the inequality using a a to the nth. And at last, we get b to the nth is smaller than a to the nth, right? So we have proved this property. For example, let's see some example. We know that 3 is smaller than 4, right? And we raise both sides of the inequality to the -2th power. That means the inequality symbol should change direction, right? So if we raise them to the -2th power, that means 3 to the -2 is greater than 4 to the -2, right? If you verify this, 3 to the -2 is actually 1/9, right? 4 to the -2 is 1/16. Which one is larger? Of course, the left-hand side is larger than the right-hand side, right? Okay, next, for another example, if we know that x is smaller than y and both x and y is a positive number, then if we raise them to the -3rd power, we will get x to the -3rd is greater than y to the -3rd. Okay, and similarly, for example, we know if we know that m is greater than or equal to n, and both m and n are non-negative, we know that m to the -1/2 is smaller than or equal to n raised to the -1/2. Okay. Any questions? No? All right, let's see the next one. Property 9. If both sides of the inequality are positive and n is positive integer, replace both sides of the inequality with their nth roots. The inequality symbol remains in the same direction. Okay. In other words, if a is smaller than b and both a and b are greater than 0 and n is a positive integer, then we will have the nth root of a is smaller than the nth root of b. Okay. Okay, to prove this, we start from n is above 0. If n is above 0, then the reciprocal of n is also above 0, right? So according to property 7, if we have a is smaller than b and both of them are above 0, we can raise both sides to 1/n, right? And then we will have this inequality here. And actually, a to the 1/n is actually the nth root of a, right? So of course, we will have the nth power, the nth root of a is smaller than the nth root of b. Also, the two numbers here are both positive number, right? Okay, so for example, if we know that 4 is smaller than 9, right? 4 is smaller than 9, and we take their second root, which is square root, and then we know that the inequality symbol remains in the same direction. So the square root of 4 is smaller than the square root of 9, right? And if we verify this, this is actually 2, and right hand side is actually 3, right? 2 is of course smaller than 3. Or for another example, if you know that m is greater than or equal to n, and both m and n are non-negative, and we take their fourth root, then the inequality sign does not change direction. So that means the fourth root of m should be greater than or equal to the fourth root of n, right? Any questions? No? Okay, let's see property 10, chain rules. Okay, there are several sub rules. First one, if A is smaller than B and B is smaller than C, then A should be smaller than C, right? I'm not gonna explain this because I think this should be obvious to you, right? For example, 2 is smaller than 3 and 3 is smaller than 5. And we can get 2 is smaller than 5, right? Okay, next, if A is smaller than B and C is smaller than D, then we will have A plus C is smaller than B plus D, right? Because here A and C are the smaller numbers and B and D are the larger numbers, right? So the sum of two smaller numbers should be smaller than the sum of two larger numbers, right? For example, we know that 2 is smaller than 3 and 5 is smaller than 6. So that means if we add the left-hand side, which is 2 plus 5, this should be smaller than adding the right-hand side, which is 3 plus 6, right? Okay. Next one, if A is smaller than B, and both A and B are positive numbers, and also we know that C is smaller than D, and both C and D are positive numbers, then we know that the product of A and C should be smaller than the product of B and D. Okay, note that this rule only applies when all the numbers are positive. Okay, when they are not, you need to prove or you need to show some anti-examples. Okay, for example, we know that 2 is smaller than 3 and both 2 and 3 are positive numbers, and 4 is smaller than 5 and also both 4 and 5 are positive numbers. Then we know that the product of 2 and 4 should be smaller than the product of 3 and 5, right? Okay, next, if we have two negative numbers, A and B, and we know that A is smaller than B, and two other smaller numbers, C and D, and we know that C is smaller than D, then the product of A and C should be greater than B and D. Okay, for example, we know that -3 is smaller than -2, and both -3 and -2 are negative numbers. And also we know that -5 is smaller than -4, right? And both -5 and -4 are negative numbers. And then if we time the left-hand side, we will get -3 times -5. And right-hand side is -2 times -4, right? Of course, the left-hand side is larger than the right-hand side. Okay, this is another useful property. Okay, and pay attention that if A is smaller than B and C is smaller than D, we cannot decide the relationship between A and B and C and D, A minus B and C minus D. Also, we cannot decide the relationship between A divided by B and C divided by D. Why? Because smaller number minus by a smaller number is the left-hand side, right? Right-hand side is, sorry, I made a typo here. This should be A minus C. And this should be B minus D. Can you correct your notes if you have printed them out? Can you make the correction? And also this should be A over C and B over D. You cannot decide the relationship between A minus C and B minus D, right? Because A minus C is just the difference between two smaller numbers. We do not know the difference is smaller than the difference between B and D or not. Okay, for example, if we have a smaller than 2, right? And we also know that 1 is smaller than 2, right? So this is or A, this is or B, this is or C, this is or D. And A minus C would be 0, right? And B minus D would also be 0. So 0 is equal to 0. This is one case, right? For another case, if we have 1 is smaller than 2, and we also know that 4 is smaller than 6. Okay, so 1 minus 4 is minus 3. This is the left hand side, right? Right hand side, we will have 2 minus 6, which will have minus 4, right? Minus 3 is larger than minus 4, right? Also, we can have, for example, 2 is smaller than 8. 1 is smaller than 2, right? How about 3? And the difference between the left hand side is 2 minus 1, which is 1. And right hand side is 8 minus 3, which is 5, right? And this time 1 is smaller than 5. So the left hand side could be equal to or smaller than or greater than the right hand side, right? So you need to pay attention to this. If A is smaller than B and C is smaller than D, we can now decide the relationship between the difference or the division between the two smaller numbers and the difference or the division between the two larger numbers. Okay? Any questions? All right, let's see the last property, which we call it reciprocal rules. First, if A is smaller than B and both A and B are positive numbers, then if we flip the numbers, which means we get their reciprocals, 1 over A should be larger than 1 over B. Okay, how do we prove this? We start from the given information, which is A is smaller than B, right? Note that both A and B are positive numbers, so their product should also be a positive number, right? And according to property 5, we can divide both sides of the inequalities with the product of A and B, right? And then we will get 1 over B is smaller than 1 over A. Of course, both of the two numbers are also positive numbers. This means 1 over A is greater than 1 over B, right? So this proves the property here. For example, if we have 2 is smaller than 3 and 2 and 3 are both positive numbers, right? And if we get their reciprocal, 1 over 2 is of course larger than 1 over 3, right? Okay, the second case, if both A and B are negative numbers, and also we know that A is smaller than B, then if we get their reciprocals, 1 over A should be larger than 1 over B. Okay, the method we use to prove this property is the same with the method we have just used. You can have a look at this after the class. For example, we know that minus 3 is smaller than minus 2, right? And both of the numbers are negative numbers. And then if we get their reciprocals, we know that minus 1/3 should be larger than minus 1/2. right? Okay, any questions? So basically, these are the simple rules when you need to solve or simplify the inequalities, okay? After these properties, I have included some practices. Actually, these practices are from your assignment 40. Okay, I have made a note here. So after this class, you need to complete these practices, okay? You don't have to write your solutions here. You can just write your solutions on the answer sheet of assignment 40 because these practices are actually from that assignment, okay? If you still don't know how to solve them, you can refer to my notes in previous pages. Okay, actually, these practices are can be solved using the simple rules we have discussed. Okay, I'll show you one of the solutions. Okay, how about this one? Okay, how about this one? We know that A is a ratio between two large numbers, right? And B is another ratio between two large numbers. How do you decide which number is larger? Okay, so by observation, I think one of the ideas is to flip the numerator and denominator. Why? Because if you flip them, you can see that the reciprocal of A is actually this one over right? And we can detach the numerator to two parts. First part is the same with the denominator, right? And second part is plus one. Okay, so this is actually 1 plus 1 over a very large number, right? And we do the same transformation to B. The reciprocal of B is over, which is plus 1 over, okay, which can be simplified to 1 plus 1 over a very large number. Okay, and now can you see how do we compare these two numbers? We can compare the two numbers here, right? So which one of these two numbers are larger? Can you tell me? Suppose we call this suppose we call this C and call this part D. So which one is larger? Okay, Emily says D. How about Dora? Why? Why C is larger? Okay, so can you tell me which of the two numbers is larger? the second. You mean we should put a sign like this, right? So how many digits we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 digits. 1, 2, 3, 4, 5, 6, 7, 8. This number only has 8 digits. So which one is larger? So left-hand side, right? Okay, left-hand side is larger. So that means if we get their reciprocals, according to the rules we have learned, what symbol should I put here? If the denominator is larger and both of the two numbers are positive numbers, larger denominator means smaller numbers, right? So we should put a sign like this. So that means C should be smaller than D, right? So if C is smaller than D, that means, okay, C is smaller than D, means 1 plus C is smaller than 1 plus D, right? So what is 1 plus C? 1 plus C is 1 over A, right? And what is 1 plus D? 1 plus D is 1 over B, right? And remember that both A and B are positive numbers, right? So if you have A and B are positive numbers, we can time A, B to both sides of the inequality, and the inequality does not change direction, right? So this means left-hand side is, after we canceling A, left-hand side is B, and right-hand side after we cancels B, which is A, right? So that means B is smaller than A, right? So this is how we compare these two numbers. Okay. All right, I'll leave the rest of the practices for you to solve after this class, okay? Again, like I said, you can solve them on the assignment 40 paper, on that paper, not here, okay? And remember to submit your answer sheet onto Google Classroom. Under the title, assignment, there is a title saying assignment 41, resubmit of assignment 40 something, okay? Under this title. Understand? Okay, so we have spent some time on the first part, and let's see the second part. Second part is, how do we solve or simplify some simple inequalities? Okay, I'll take some examples. Let's take some examples to illustrate this point. Okay, so basically the idea is to, just like solving an equation, we should conduct equivalent transformation using the properties we have learned, okay? All right, let's see this example. This is actually from your assignment 40, question 7. Okay, find all x such that 3x minus 7 is greater than or equal to 8 minus 2x. So how do we solve this? Okay, remember that we conduct equivalent transformation. So the original inequalities is equivalent to, we can move all the x's and combine them to the left-hand side, right? So this is equivalent to 3x plus 2x. Remember that if you move minus 2x to the right and to the left-hand side of the equation, you need to change the sign to positive, right? So it's greater than or equal to 8. So we have a minus 7. Minus 7 to the right-hand side becomes plus 7, right? Okay, so again, this is equivalent to 5x greater than or equal to 15, right? And then we can divide both sides of the inequality using a 5. 5 is positive, so the inequality sign does not change direction. So that is equivalent to x is greater than or equal to 3, right? So this is our final solution. Or sometimes you can also use the notation here. X belongs to an interval 3 to positive infinity. Okay. All right. So for example, if you have a solution like x is greater than 2, this is equivalent to x belong to a interval 2 to positive infinity. You understand this? These are just two different notations. Okay, you can choose either of them. Any questions? No? Okay, let's see. Okay, there is a practice. I need you to, again, complete this practice after this class, right? Okay, this is actually from assignment 40, question 8. So complete that question on your worksheet after this class, okay, by yourself. Okay, and the third part is how do we solve or simplify combined inequalities? Okay, again, I'll set you an example. Let's see an example. And then I'll leave some of the practices for you to solve after this class. Okay, so first example, this is a combined inequalities. The method is actually similar to the one we used to solve combined equations. Okay, so we have two methods to solve these combined inequalities. First method, we can detach these two different inequalities, right? So this is actually the first inequality, and this is another inequality, right? So we can detach them to 2. Okay, so this means, first of all, we need to ensure that 5 is smaller than or equal to 2x plus 3, right? This is the first part. And remember that there is a second part, which is 2x plus 3 should be smaller than or equal to 15, right? And then we solve these two inequalities and combine the results. Okay, so this is equivalent to, first inequality is actually 2x larger than 2, right? Second one is 2x is smaller than or equal to 12, right? Okay, so this means x is greater than or equal to 1, and x is smaller than or equal to 6, right? And how do we combine this result? We can draw a number axis to show how we can combine this. Okay, first solution is x is greater than or equal to 1. Suppose this is 1. That means this is our solution, right? All the numbers that is equal to or greater than 1. The second inequality tells us we should find that all x's that is equal to or smaller than 6. So this is our second solution, right? So the intersection part, which is a shaded area here, is the final solution, right? This means x should be equal to or greater than 1 or equal to or less than 6, right? Or you can use the other notation, which is x belongs to an interval, which is 1 to 6 inclusive, right? If it is inclusive, you should use the square brackets. Okay. Any questions? Okay, this is the first method, okay? And we can also have a second method, which we can directly solve directly, which means we can do the transformation at the same time to both of the two inequalities, right? So the original inequality is equivalent to, first we can minus 3 to both sides of the inequality, right? This gives us 2x 12, right? And then we can divide a 2 to both sides of the two inequalities, which gives us 1 equal to or smaller than x equal to or smaller than 6, right? And then you can see that we directly find the results, which is x equal to or greater than 1 or equal to or smaller than 6. Okay, you can choose either method. But sometimes I think the first method is more generic. Okay, any questions? No? All right, let's see another example. So just as I said, the first method is more generic. So let's try the first method first, okay? Method 1. Detach this to two different inequalities. First one is 2x plus 5, right? This is the first one. Next one is from here to here, right? Which means, sorry, I haven't finished this. 2 plus x is greater than 5 minus 3x, right? This is the first part. Next part should be this one, right? 5 minus 3x is greater than 8, right? The original inequalities is equivalent to the system of linear inequalities, which is equivalent to, now let's solve each of the inequalities separately. First one is 4x greater than 3, right? And second one is 3x smaller than minus 3, right? Okay, so this is equivalent to, first x is greater than 3/4, right? And second inequality gives us x should be smaller than -1, right? So next we should find the intersection area. First is x should be greater than 3/4. So greater than 3/4 is this one, right? Okay, so note that if it's exclusive, it's an exclusive point, you should use a circle, not a dot, okay? Circle means they removed this value because x cannot be 3/4. So we have to remove this particular point, okay? And the second inequality tells us x should be smaller than -1. So -1 should be on the left-hand side of 3/4, right? So this is -1. Second inequality tells us that x should be smaller than this value. So is there any intersection part? The answer is no, right? The two areas cannot overlap. So what does this mean? This means there is no solution, right? So we can make the conclusion, there is no solution. Or you can use the other notation, which means x belongs to an empty set, okay? This sign here means an empty set. Empty set. That means there is no value in that set, okay? You understand? All right. Do you understand? Do you know how to solve it now? Okay, so how about method 2? Can we use method 2 here? So as you can see here, method 2 is not applicable here, right? You cannot do the transformation to both of the inequalities and solve the inequality. So method 2 is not very applicable. So it does not work. So this is why I said that method 1 is more generic. So you can always try. You can try method 2 first, and if it doesn't work, then you can turn to method 1. Okay, that is to detach the system into different separate inequalities and solve. Okay. Any questions? No? Okay, let's see. Next one. Okay, there are 2 practices after this key point, right? So the first one is from assignment 40, question 3. And next one is actually from question 10. This is actually how we apply this method to solve simple combined inequalities, okay? So please complete these 2 practices on your worksheet and submit that onto Google Classroom after this class. Okay. All right. Key point 4 is how do we graph inequalities in 1D number axis? Actually, we have already touched this in our previous slides. Okay. So for example, note that this can help you find solutions of several combined inequalities, just like we did in our previous slides. Okay, here I'll only set you some examples to illustrate this. Okay, first, if we have x is greater than 2, how do we draw this on the number axis? First, you can draw number axis and then draw a -2 here, right? Because x cannot be -2, so we need to use a circle. That means remove -2 from the solutions, and x could be any number that is above -2. Okay, or you can also use the notation like this: x belongs to a set, which is -2 to positive infinity. Okay. Next example, if we have x is greater than or equal to -2. So what is the difference between the first one and second one? The difference is that the first one means x is strictly above -2, right? And x cannot be equal to -2. But in the second one, x can be -2. So that means we need to use a dot instead of a circle, right? The dot here means x can be the point here, okay? X can be any point, including -2, or any value that is above -2, okay? And it also corresponds to this notation here: x belongs to an interval, which is -2 to positive infinity. Okay, note that 2 symbols here are also different. One is round brackets, one is square brackets. Okay. All right, third one, if we have x is strictly greater than -2 and smaller than or equal to 1, how do we draw this? Again, first draw a number line or number axis, and x is greater than -2. That means we need to draw a circle on -2 here, right? And then this means The line here means x could be any number that is above -2. And then x is smaller than or equal to 1. So x, use a dot here. That means x could be 1 or any number here below 1, right? And the intersection part here means x is greater than -2 or smaller than or equal to 1, okay? Remember that the intersection here corresponds to the expression here. Or you can also use the notation like x belongs to an interval, -2 to 1, okay? Left-hand side, exclusive. Right-hand side, inclusive, okay? Okay, the fourth. If we have a combination, x is greater than or equal to -1, and x is above 3. Okay, if we draw this on the number line, we can see that x is greater than -1 or equal to -1 is here, right? And x is greater than 3 is here. What is the intersecting part? What is the overlapped part? The shaded area is the overlapped part, right? So this means this expression can be simplified to only x is above 0, x is above 3, okay? Because this is the overlapped area. Or you can use the other notation, x belongs to the interval of 3 to positive infinity. Okay, how about the fifth? Fifth is also a combination of two inequalities. First one is x is equal to or smaller than -1. So this corresponds to the left-hand side, left part of the graph, okay? And next one we have x is greater than 3. So first of all, draw a circle on the 3. And then any value that is greater than 3 is here, right? So what is the overlapping part? There is no overlapped part, right? So this means there's no solution. Or you can also use the other notation, x belongs to an empty set. Okay. Now, do you know how to graph inequalities in the 1D number axis now? Any questions? So in practice, oftentimes we use this to help us find the solutions. Any questions? No? Okay, next. Okay, the practice follow this key point is left for you to solve after this class, okay? Next, let's have a look at how do we graph inequalities in the 2D Cartesian plane. So remember that, recall that how do we draw the lines on the 2D Cartesian plane? Okay, suppose we have a line, y is kx plus b. Suppose the slope of this line exists. And this line should be here, right? We can draw this line on the 2D Cartesian plane, right? If we know the equation of this line, we can draw the line here. Okay, suppose this is graph of this line. And for any region that is above this line, can be denoted with y is greater than kx plus b. Right? And for any region that below this line, this can be denoted as y is smaller than kx plus b. Right? Did you see why? Can you see why here? Okay, I'll give you an example. Suppose we have a line like, how about y equals x plus 1. Okay, suppose this is our line here. And suppose we have a point on this line. How about minus 1/2? Yeah, let's draw this a little larger. Yeah, I'll give you an example. Suppose we have a line y equals x plus 1. And any point that satisfies this equation should be on this line, right? So suppose we have a line minus 1/2. What is the y-axis? Y-axis should be 1/2, right? So for the region above this line, for example, if we have a point here, what is coordinate of the point here? Its x-axis should be a minus 1/2, right? How about its y-axis? If its y-axis, if its y coordinates is 1/2, then this point is actually on this line, right? And for any y coordinate that is above 1/2, the point should be on the region that is above this line, right? So that means for any point in this region, how do we represent this? This is, of course, y above or y greater than x plus 1, right? And following the same principle, for any point that is under this line, its equation can be represented by y is smaller than x plus 1, right? So more generally, if we have a line and the equation of this line is y equals kx plus b, for any point that is on the line, it should satisfy this equation, right? And for any point that is on the region above this line, its equation should be y is greater than kx plus b, right? And for the region that below this line, this can be represented by y is smaller than kx plus b, right? Do you understand? So how do we draw the inequalities on a 2D Cartesian plane? First of all, we need to find that line, right? First of all, we need to convert it to a slope-intercept form and then find this line. And then we examine if the inequality is greater than or smaller than and corresponds that to the region that is above this line or below this line, right? Okay, so we'll see an example after this, okay, to help you understand. Okay, an exception is if the slope does not exist. This is actually a very simple case, right? If the slope does not exist, that means the line is parallel to y-axis, right? And the line could be represented by an equation like x equals k, right? And of course, we know that the left-hand side should be x smaller than k, right? And the right-hand side of this line can be represented by x greater than k, right? So if you want to graph x smaller than k, you should shade this area, right? If you want to graph x is greater than k, you should shade this area, right? Okay, any questions? Practice, okay? This practice is from assignment 40, question 13. So Please do complete this after this class. Okay, next is point 6. Point 6 is about optimization problems involving two variables linear inequalities. Okay, I'll use the following example to show how do we solve such problems. Okay, so this is the most difficult part in this chapter, so please listen carefully. I think we should spend about 20 minutes on this topic. Okay. The problem is find the maximum value of 2x plus y such that the following three inequalities are satisfied. Okay, so usually we'll use graphing method to solve optimization problems like this. So we use graphing method, okay? On the next page, I'll show you how to do this. First of all, we graph this. This is called constraints. And this is called a target. A target is to find a maximum value of this target under these constraints. Usually the constraint should be a region. Okay, so first of all, let's have a look at how we can draw these constraints on 2D Cartesian plane. Okay, first of all, let's draw a coordinate. This is all y-axis, and this is all x-axis. Okay, first of all, let's draw this. What is x is smaller than 0? How do we draw this? X is smaller than 0 is the whole region that is on the left-hand side of, it's not here. X is smaller than 0. Let's use another color. This is 0, right? X is smaller than 0. That means the whole region here, right? And how about y is greater than 0? Y is greater than 0 means the whole region here, right? So according to the first two constraints, remember that the three inequalities should all be satisfied, right? So according to the first two constraints, what is the overlapped region? The overlapped region is actually the third quadrant, right? And we also need to consider the third constraint. So how do we find the region that corresponds to this inequality? Again, first, we need to find that line, right? So this inequality is equivalent to, first we solve y in terms of x, right? Y is smaller than or equal to x plus 1, right? Okay, so next, first we need to find this line. Where is y equals x plus 1? How do we find that line? First of all, it has a slope of 1, so approximately look like this, right? Next, it has a slope of 1. Sorry, a y-intercept of 0, 1, right? So this line should look like this. Okay, this line should look like this. This is our line, y equals x plus 1, right? Okay, so how about y is smaller than? or equal to x plus 1. According to the analysis in our previous slides, this should be the region that is under this line, right? Because it says y is smaller than. That means it's a region that is smaller than this line. So it corresponds to all the region below this line, right? Okay, now, can you tell me what is the overlapped area? What is the overlapped region of these three inequality? Okay, let's say this is region 1, region 2, this is region 3. What is the overlapped region of R1, R2, R3? It should be a triangle on the top left corner, right? Let's draw this. It should be a triangle here. Can you see this? Okay, so this side corresponds to the constraint x is smaller than 0. This bound corresponds to y is above 0, right? And this side corresponds to y is smaller than x plus 1, right? So R1, R2, R3, the overlap of R1, R2, R3 should be a triangle like this. Do you understand? Okay, so that means we need to find the maximum possible value of 2x plus y, satisfying that the x and y coordinates should be within this region, right? Under this constraint means within this region. Okay, next, let 2x plus y be k. That means we need to find the maximum possible value of k, right? So first of all, what is this? This is a line, right? So that means this is actually y equals minus 2x plus k, right? So this is a line, a family of lines. A family of lines with slope minus 2 and y-intercept 0k, right? Okay, so a family of lines that has slope minus 2 and y-intercept 0k. That means if we draw this on the let's use another color. If we draw this on the graph, it should look like this. Okay, this is a possible, oh, sorry. Need to use a straight line. Let's use a dot line here. Okay, it could look like, because it has a negative slope, so it has a direction like this, right? And it could look like this, or this, or this, or this, or this, or this, or this. Because it's a family of lines, right? Different case corresponding to different lines, right? But this line should be all parallel, right? So what can you tell me from the graph? where can the maximum value of k be? It can also be, or it can only be at point A or point B or point C, right? Can you see this? And apparently, because this is a simple question, apparently that at point A, k is maximum, right? Do you understand? Okay, so actually the maximum value can only happen at point A, B, or C. So we only need to calculate the 2x plus y at A, B, or C, right? So at point A, what is 2x plus y? So at point A, what is x? X is 0, y is 1, right? Point B is 0, 0. Point C is -1, 0. So at point A, 2x plus y is actually 0 plus 1, which is 1, right? At point B, it's 0 plus 0 is 0. At point C, we have -2 plus 0, which is -2, right? So which one is largest? Apparently that at C, we have a maximum of 1 for 2x plus y, right? So basically, this is how we find the maximum value given a set of constraints. Okay, so let's summarize. Okay, you can read my lecture slides. Do not read this because this is not very clear. You can read the lecture slides I sent you to your email. Okay, that is clearer. So next, let's make a summary. How do we find the maximum or minimum value given a set of constraints? What is the takeaway? Takeaways are, suppose we must minimize or maximize a linear expression in one or two variables such that the variables satisfy a set of linear inequalities like this. Okay, this is our constraints. Suppose further that the set of all points that satisfies the inequalities in a bounded region. Okay, this is our bounded region, right? In this example, this is our bounded region, which corresponds to the set of constraints. Okay, instead of extending indefinitely in some direction. And the inequalities are non-strict so that the boundary points satisfy them. Sorry, there is another typo. This should be equal to or smaller than, okay? Just make the correction by yourself. Otherwise, x cannot reach 0, okay? This should be equal to or greater than. So just put the equality sign as well. Then the point inside the bounded region that optimizes the desired expression must be a corner, a vertex of the region. Therefore, we only need to calculate and compare the value of the expression to be optimized at the vertex to find the max or mean. Okay. Or let's make a summary about the method. First, you need to find the bounded region, which corresponds to the set of constraints. Second, you need to find the coordinates of each vertex of the bounded region, such as or A, O, or B here. Last, calculate the value of the expression be optimized at each vertex, and then find the max or min, right? Do you understand? Okay, so there is a practice after this example. Okay, Dora has a question. Is point A always 0, 1? Not necessarily. So there is a practice. When you do this practice, you will see that the bounded area could be anywhere. Okay, so for example, if you draw the bounded area according to this set of constraints, for example, you have a line like this, another line like this, and this could be your bounded area. Okay, and these 4 points are the vertex. Okay, so first find the bounded region. Next, find the coordinates of each vertex. Okay, find the coordinates of the 4 vertex. Then calculate the value of expression to be optimized at each vertex, and then find the max or min. Okay, if you still don't know how to solve this, just refer to the example I gave you here. Okay. Any questions? Okay, just try to solve this by yourself. And next time, I'll show you how to do this. Okay, the last key point is the word problems that involves inequalities. Okay, this is actually just like the word problems in the equations chapter. First, we need to translate the word problem into mathematical language, and then use all the methods we have learned in part 1 through part 6 of this slides to solve it. Okay, I'll set you an example. Okay, let's see the last example. Actually, last 2 examples. Okay, example 1. This is a simple inequality problem. Okay, so first of all, I have $230 and I'm a bookstore. I'm at a bookstore. I love books, so I want to buy as many as I can. The books I want to buy each cost $17. At most, how many books can I buy and still have at least $25 left for dinner? Okay, to solve this, usually we'll use a letter to denote the unknown quantities that we want to solve, right? So here we can let X be the number of books I can buy. So according to the requirement, total dollar is 230, subtracted by the cost of books, which is 17 times X. This is the total cost of books, right? And this is the remaining money, right? The remaining money should be at least 25. That means 25 or 25 above, right? So we have a relationship like this. And also note that because X is the number of books, right? So X should be non-positive number, right? And X should be a non-positive integer, actually. So this is our constraint. And we need to find the scope of X, right? So let's solve this. Okay, first, inequality gives us 17x equals or smaller than 205, right? Next, x is equal to or above 0. And x belongs to an integer. So this is equivalent to, first of all, x is smaller than or equal to 12.06. Next one is x is larger than or equal to 0, and x belongs to an integer. Okay, so by combining this, x is within this region, 0 and 12. Of course, x is an integer, right? So what is the maximum number that x could be? Therefore, at most, x is 12, right? That means I can buy 12 books at most. Okay, any questions? Oh, all right, there is a last example. The next practice follows this example is for you to solve, okay? This is assignment 40, question 14. And after that, we have a last example. Do you want me to finish this or shall we do this in our next lecture? This is actually a word problem that involves optimization, just like what we do, previous slides. First, we need to find that region, then vertex, then different values at the vertex. Do you want me to finish it or shall we do this next time? It's your choice. Yes, the homework is assignment 40, question 17, which is very similar to the example here. So tell me, do you want to do it now? Press 1 for now. Press 2 for next time. If you choose next time, you need to read this example thoroughly by yourself, okay? This will guide you how to solve optimization word problems. Okay, let's do it now then. Okay, please read these questions first. Okay, I'll read it for you. For every mile of highway on land, the city needs 2 truckloads of asphalt and 1 gallon of paint. For every mile of highway on bridges, the city needs 1 truckload of asphalt and 3 gallons of paint. City has 50 truckloads of asphalt and 80 gallons of paint. So let's make summary. So for any highway on land, 1 mile highway on land need 2 truckload asphalt and 1 gallon of paint, right? And for 1 mile highway on bridges, we need 1 truckload asphalt plus 3 gallons of paint, right? This is the given information. And we also know that in total, the city has 50 truckloads of asphalt and 80 gallons of paint. The question is, suppose city is on an island and must build at least 25 miles of highway on bridges to reach other islands. Now, what is the largest total number of miles of highway city can build? Okay, so basically the question is, some of the highway must build on line, right? Suppose X miles of highway built on line, and y miles of highway built on bridges. Okay, so let's first use two variables to denote these two quantities. Let x denote number of miles of highway that is not on bridge. The city can build. And let y denote number of miles of highway that must be on bridges. That must be on bridge the city can build. Okay. Then we know that total truckloads as total truckload of asphalt used is 2x plus 1y, right? Do you see why? Because for 1 mile highway that is not on bridge, we need 2 truckloads of asphalt, right? So this is a total number of truckloads of asphalt for highway that is not on bridge. And for any mile of highway that is on the bridge, we need 1 truckload of asphalt, right? So this is the total number of truckloads of asphalt we use. And because we only have a total number we only have 50 truckloads of asphalt in total. So this number should be equal to or less than 50, right? Do you understand? This is our first constraint. Also, we know that the total gallons of paint used is how much? For every mile of highway that is not on the bridge, we need 1 gallon of paint, right? So 1x. And for any 1 mile highway that is on the bridge, we need 3 gallons of paint, right? So plus 3y. This is the total gallons of paint we use. And because we only have 80 gallons of paint, so this number should be equal to or smaller than 80, right? This is another constraint. Okay, and are there any other constraints? Yes, of course there is. It also specified that at least 20 miles of highway should be on bridges, right? So that means y is total miles of highway that must be on bridges, right? This translates to y should be at least 25, which means y should be 25 or any number that is greater than 25, right? And also because x and y denotes the miles of highway that is built, so both x and y should be equal to or above 0, right? Do you understand? So these are all constraints response to this problem. And what is the target? What is the target? The target is to maximize or minimize. Target is to maximize, right? Maximize which one? So let's revisit the question. The question is, what is the largest total number of miles of highway? Largest total number of miles. That means to maximize x plus y, right? Because x plus y is total number of miles, right? Okay, so this question is actually to find the maximum value that x plus y can be under this constraint, right? And in this way, they convert it to a pure calculation problem. Okay, so let's have a look at this calculation problem. Okay, I copied the problem here. Now the problem is a pure calculation problem as follows. The constraints are 2x plus 1y is equal to or less than 50. 1x plus 3y is equal to or less than 80. Y is equal to or above 25. And x is above 0 or equal to 0. Y is above or equal to 0, right? Target is to maximize x plus y, right? So let's just follow the steps we have discussed. First of all, you still remember the steps? First of all, we need to draw the boundary, right? Okay, first of all, let's draw the boundary. Okay, so let's start from the first one. So let's label them as 1, 2, 3, 4, and 5. First one is equivalent to, remember, we need to, it's better to convert it to slope intercept form, right? So the first one is equivalent to y equal to or smaller than minus 2x plus 50. Okay, and this is, we need to find this line first, right? Okay, next, second one is actually y equals or smaller than minus 1/3 of x plus 80/3, right? Okay, and then let's draw the 2D Cartesian plane. Okay, this is our y and this is our x. Okay, first let's find the line that is y equals 2x plus 50. So where is this line? First of all, it has a negative slope, right? Negative slope means it has a direction like this. And the y-intercept is 0, 50. So it's about here, right? And this is a vertex, point A. Coordinate is 0, 50. And there's another point here. So let's leave these coordinates later because we don't necessarily need the coordinates here, right? This line is y equals 2x plus 50. Okay, and we have another line which specifies by the second inequality, which is y equals minus 1/3 of x plus 80/3, right? Where is this line? First of all, it has a slope of minus 1/3. Minus 1/3 is smaller than the slope of the first line, right? I mean the absolute value. So this line is more flat, so it has a slope like this, right? Can you see that? Let's use another color. So this line has a slope of -2, and the second line has a slope of -1/3, which the angle here should be smaller than the angle here, right? Because the absolute value of the slope is smaller than the previous line. Can you see that? Okay, so roughly this line have position like this. And this is our second line. Which is y equals -1/3 of x plus 80/3. So 80/3 is around 6.67, right? So here, what is the point here? This point is 25, right? And 26.67 is a little larger than 25. So this point should be on the right-hand side of this point, right? So it's okay if you don't, it's okay if you don't draw the lines exactly where they are, but all the relative positions of the points should be maintained. Do you understand? That means you can't draw the second line like this because this is not accurate, okay? The relative positions of the points must be maintained. So for example, the point M should be on the right-hand side of point N, okay? Okay, this is our second line. And note that you need to also verify if this point here is below point A, okay? The point here, okay, let's write the coordinate here. This is 80/3. And what is the y coordinate of this point? Oh, sorry, this should be 80/3. And what is this point? This point should be 1, y is 0. So should be 80, right? This should be 80. Okay, let's mark all the points here. This is 0, 80/3. And this point here is 80/0. And this point here is 25/0, right? Okay, do you understand? So far we have 4 points, 2 lines. Any questions? Hello, any questions? No? Okay, next we need to draw y equal to or above 25, right? So y is 25, this should be a horizontal line, right? Could be here, 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 or here, right? We do not know the relative position between this line and this intersection point here, right? Remember that we need to maintain all the relative positions. So first of all, we need to find the position of this point. So how do you find the intersection point? We need to solve the system of these two equations. Which system? The system that involves the first two lines, right? Okay, so that means we need to find this solution. Okay, can you tell me what is x? 2x minus 1/3 of x equals can times 3 to both sides. Okay, this gives us 5x equals 70, right? So x is 14, right? So the x coordinate here is 14. How about the y coordinate? Y coordinate, if we put 14 back to the equation here, y equals minus 2 times 14 plus 50, which is 22, right? So this point is 14, 22. Okay, we can wipe this. All right, so far we have 5 points and 2 lines. Do you have any questions? No? Okay, next we need to draw y is above or equal to 25. Okay, so first of all, we need to find the line which is y equals 25. So where is this line? It should be somewhere above this point. Somewhere above this point, right? And somewhere below this point, right? Because 80 over 3 is 26.67, right? Okay, so this line should be somewhere in between. So for example, it could be here, right? So let's use another color. Okay, so this line should be somewhere here. This is our y equals 25. Do you understand? Okay, let's draw this more clearer. Oh, it's not here. Okay, this is y equals 25. So y is above or equal to 25 is all the region that is above this line, right? Okay, let's mark this using a symbol like this. Okay, so the first region is below this line, right? And second region is below the green line. Okay, below the green line. And third region is above the red dotted line, right? And also, there are two other constraints, which is x is above 0 and y is above 0. So that means we only need to consider the region on the first quadrant, right? Okay, so what is the intersection? What is the overlapped area? Can you tell me what is the overlapped region? Okay, I'll give you some letters, point A, point B, point C, point D, point E, point F, point G. Okay, so can you tell me what is the overlapped region? Considering 1, 2, 3, 4, 5. What is the overlapped region? Can you see that? The region, it should be an area, not a point. Okay, okay, let me tell you, the overlapped region is here. Can you see that? Is a small triangle EFG. This is the overlapped area. Why? Because the region must below this green line, right? Below this green line. That means we have a boundary here, right? And it also must be below the blue line. So any region that is blue, below the blue line, which is a region like this, right? And also the region must be to the right-hand side of the y-axis. So this is another boundary. And this line must be above y equals 25. So y equals 25 is another boundary, right? You see that? Okay, Emily understands. How about Dora? Dora? Okay. Okay, you understand? Okay. So that means all the 5 inequalities corresponds to the area EFG, right? Remember that the takeaway is the maximum or minimum value can only be achieved at the vertex of the boundary, right? So we only need to consider the x plus y value at point E or point F or point G, okay? So first of all, we need to find the coordinates of these 3 points. We have already found coordinates of E, right? Which is 0, 80/3. How about F? F is the intersection point between y equals 25 and x being 0, right? So the coordinate of F is 0, 25. How about G? G is also an intersection point, right? Which is an intersection point between these 2 lines. So what is the solution? The solution is which means x is 5, right? Okay, so that means we find the coordinates of the 3 vertex of the overlapped area. Next, we need to find the value of x plus y. Remember, this is our target, right? So at point E, what is the value of x plus y? At point E, the value of x plus y is 0 plus 80 over 3, which is 80 over 3, right? And at point F, what is the value of x plus y? X plus y is 0 plus 25, which is 25, right? So how about at point G? At point G, x plus y equals 5 plus 25 equals 30, right? So at which point do we have a maximum value? Now you can see that at point G, we have a maximum value of 30, right? So that means when x is 5 and y is 25, we have a maximum value of x plus y, which is 30, right? And back to the question, x5 means we must build 5 miles of road that is not on bridge and build another 25 miles road on the bridge, right? And total miles of road is 30. You understand? This is how we optimize the target function. Okay, I hope you understand how we solve this now. Okay, the practice after this example is for you to solve after this class. Okay, this is very similar to what we have experienced in today's class. If you have any questions, just let me know. Okay. This seems a little complex, but the principle behind it is very simple. Okay, just these 3 sentences. First, find the bounded region. Second, find the coordinates of each vertex of the bounded region. Third, calculate the value of the expression to be optimized at each vertex, and then find the maximum or mean. Okay. All right, if you don't have any questions, please continue doing your assignment 40 and submit it onto Google Classroom, okay? And there's the title here. I'll show you how to submit it. Oh, where is it?